Hey, this is Lance from LangChain. Earlier this fall, we put out a State of AI Agents report where we asked 1,600 people in the AI industry what are top use cases for agents. Now, we noticed that the top reported use case is research and summarization. And this is something I've been doing quite a lot. So I want to talk about an architecture that I've been using for automated research and summarization and show how to build this using Llama 3.3. Now I want to show the architecture that I've been using for report generation and research, and I consider it to be a multi-agent system. And first, it's worth reflecting on what even is an agent. In simple terms, I think of an agent as an application where an LLM directs the overall control flow. So like a RAG app, for example, the control flow is always fixed. It does a retrieval and then passes to an LLM. The LLM produces an answer. In an agent, the flow of the application is dictated by the LLM itself. So in this case, what happens is I pass in a topic, I pass in an outline, and an LLM then creates some number of report sections. Now, it's free to decide however many sections it wants based on what I provide. So it could be one section, it could be 20 sections. So this is really what dictates the entire flow of the downstream application, how many report sections it chooses to produce. Now, I like to do it this way because this allows me to, one, look at those sections, for example, in debugging, and determine if I like the outline or not. And I use this to iterate on this planning prompt quite a bit when I was building this. So that's kind of point one. Point two is that when you have your agent produce these report sections up front, you can then parallelize the writing of many of those sections. So it actually allows for an efficient overall writing process. Now what happens is I create some number of sections first, and everything that's considered a main body section that requires web research is determined by this planner. So the planner basically tags every section and says this is an intro, this is a conclusion, they do not need research. Everything that's considered main body does need research. If it needs research, it goes to this research phase where I have another LLM, you can think about that as like a sub-agent, basically spawn a bunch of different search queries and kick off web search. And then based on the results of web search, do some more transformations on those results and write the section. So that section writing is parallelized for all main body sections of the report. Now this is another interesting point. I found that quality is a lot better if you write sections individually rather than asking your assistant or agent to write the entire report in one shot. So that's another thing I do highlight here. And finally, we have another LLM reflect on all the main body sections that you wrote through research and then write any final sections like intro and conclusion. I do this because I found a sequential writing process produces overall better results. Like if the introduction and conclusion actually looks at everything you've done in the main bodies, they're a lot better than if you just produce everything in parallel and then your intro and conclusion may be totally disjointed from what you actually wrote in the main body. So it's a subtle point, but I found it produces much better report quality. Now I want to show how to build this using Llama 3.3 and NVIDIA NIM. Now what's really cool about this is Llama 3.3 is a new release from Meta. I'm sure many people have heard about this. The cool thing about it is that it packs in the performance of a much larger prior model, Llama 4 or 5B, with 6x fewer parameters. So it's faster to run, it's easier to serve. Now the catch here is that I was really excited to try this, but 70 billion parameters is too large to run locally on my laptop. I have only 32 gigs of RAM. So you do, at least for many people, need to find some inference provider. And this is where NVIDIA NIM comes in. It's a really nice way to run models, and they're all hosted for you. So that's kind of how these two pieces come together. I'm going to show you how to run Llama 3.3 on NVIDIA NIM as a really easy and nice option. So before I dive into the code, I just want to mention two things quickly. The cookbook, or all the code, is going to be linked to this video. And also you're going to see in the cookbook itself, there's going to be a button for this NVIDIA Launchable. So this will actually allow you to deploy the notebook on a GPU with one click, and the environment is all pre-configured for you. So it's actually a very nice way to also get started quickly if you want to, for example, actually deploy this with your own GPU. So if I open up the notebook here, you'll see that this is a nice diagram of the overall multi-agent architecture we're going to build. So we're just going to set some API keys here. Just make sure you have your NVIDIA API keys set to access. And for tracing, we'll use Langssmith. Now, importantly, you do need Tavily for web search. Now, Tavily is a very nice, convenient web search engine. It's free to use up to, I think, 1,000 requests, and I like it a lot. So I use it with a lot of different agents. So go ahead and grab that. And that's really all I need to get started. Now, here's where the fun begins. So basically, if you look at LangChain's integration with Chat NVIDIA, all I need to do is pass meta Llama 3.3 70B instruct as the model name, and you're going to load that as your LLM. Now, once we've done that, we can go ahead and just invoke that using llm.invoke, pass an input, and you can see the model will run. So I want to show you one very useful trick that we're going to be using throughout this agent. So LangChain has this with structured outputs method available with many different LLMs, NVIDIA included. And what's really nice is you can just pass a schema, in this case a pedantic model, to that with structured output. And then you can very simply invoke your LLM. In this case, we can supply a system prompt, human message, to that structured LLM that we created right here. In this case, here's a toy example. My system prompt says, create a well-optimized search query. And my schema has search query category as the two fields in my pedantic model. I can run, and I can actually extract then each of those fields from the output object, which is a pedantic model. So there you go. So the ability to do structured output generation is very generally useful with LLMs, and you'll see that we use it quite a bit right here. Now let's kind of walk through this architecture and kind of go through each piece in detail. So we're going to start here where the user, we provide a topic and a structure, okay? And we're going to have our LLM first generate a report plan. So why do I do this? I've found that when I've done a lot of report generation, it's nice to start with a plan for the report. For one, you can debug it independently, and two, you can actually then parallelize writing all of these sections, so it actually makes the overall process faster, rather than a sequential process of writing each section individually, and often of higher quality than trying to do one-shot report generation. So let's talk about the two inputs we're going to provide to kick this off. So one is a report structure. I can just lay this out in natural language. Here's the type of report I want to generate. It should have an introduction, it should have a conclusion, and it should have some main body sections. So this is really nice because it's entirely configurable by the user in natural language. That's one. And two is the topic. So give me an overview of these processing units, GPU versus CPU, okay? Now to kick this off, I'm going to call this generate report plan function here. And you can see we define that right here. So one thing I want to call out is we're actually going to use LangGraph to build this overall agent, but what's really nice about LangGraph is each node in LangGraph, when you build a LangGraph agent, is just a function, okay? So this is just a good old Python function, and what you're taking in is state. Now this state you can see we define up here is report state right here. This is just a type dict with a bunch of different fields that we're going to use throughout the lifetime of our agent. So what's cool about LangGraph is you can define this state, which is passed between all the nodes as your agent runs, and these fields are just populated by the agent as it goes. So here's really the main intuition in this initial generate report plan node. What we're doing here is, first, we're going to generate some search queries, okay? Then we're going to do a web search here. And finally, we're going to produce a structured output that takes in the provided topic from the user, the results from web search, and the desired report structure, and produces a structured output of report sections, okay? So this is like the planning phase. We're going to generate the layout of the report first. So first question is, where do these sections come from? Well, you see right here, this LM with structured output, we pass in sections. If you go up in the notebook, right here, you see that we define a pedantic model for a report section, okay? So that's just basically has a name, a description, whether or not research is necessary on that section, and the content. So this is basically like the core unit of a report. It's just a section, and we just define sections as a list of those section objects. That's all it happens. So we basically just take this and we pass it to Llama 3.3 using with structured output, which I showed above, same idea, and then invoke this with our system prompt. Now the system prompt, we format it right up here. We add the topic, we add the report structure, we add the results from web search. This produces the sections of the report. And once you understand this, everything else downstream is actually pretty simple. So this is pretty neat. I went ahead and ran that generate report plan. I passed in a topic right here. I passed in the structure. We talked about that right here. And a few other parameters, number of queries, and some Tavily search parameters. And you can see here are the sections it produces. So again, this is a structured object using that with structured output method. I get an introduction, I get a conclusion, CPU, GPU. Very nice and tight, presents a nice scoping of how I want the report to go. So this is really cool because I can investigate this planning phase prior to going forward with the overall research. So go back to our diagram. We've just talked through this. We've talked about I'm the user, I give it a topic, I give it some structure. My planner then produces report sections. And again, this is just using structured outputs with Llama 3.3. Pretty cool. Now the next thing I need to do is actually do research. Okay. So research is the next phase that actually requires web. So in this case, again, I use a Tavily web search. Based upon the queries I generate in this research phase, I ping my search engine, I get results, and I use all that to write each section of the report. So this kind of research and writing phase is going to happen per section. So we can test this out, and now you're seeing a little bit more LangGraph here. So this is what I'm just going to call the section builder. So this is going to generate some search queries, search the web, and write the section. This is going to run on each section individually. And here's the flow of what's going to happen. Generate some queries, search the web, write the section. Pretty simple. Now what's kind of neat is I can go ahead and pass in any individual section from that sections object I just created and test writing that in isolation. So in this case, let's just pick one of our sections and we'll just invoke the section builder graph. We'll pass in the section to run and we can have a look. So this will be a section on CPUs. We're going to ask it to research the core features, architecture, and implementation. And there we go. Pretty cool. So we get this kind of section on CPUs. It looks like it dug into some information about the Apple M4 chip as an example, and gives us a bunch of sources. So what happens under the hood here is if I go to that section builder, first we generate some search queries. That's our first node. Pretty intuitive. We kind of talked about that previously. Search the web. Again, just using Tavily. We hit the Tavily API. Now, a little note is we run that asynchronously to basically generate results from all those queries in parallel. And now this is the part I do want to spend a little bit of time on, the right section piece. So what's going to happen is we go ahead and create this system instruction. And we do that by formatting our section writer instructions right here. Now here's kind of where the art of prompting really comes in. You can absolutely modify this if you see fit, but I've found this to be a pretty reasonable prompt. So you basically instruct the model that you're an expert writer. Here's the topic of the section you're going to write. Here's a bunch of style guidelines, and you can customize this any way you want. Here's the source material to help you write the section. Now this is just our sources from web search, pretty easy, and some quality checks. And that's really all that's happening here. You're just having an LLM write a section of the report, you're giving it some information about the report, and you're giving it all the results from web search. And you can see that's all done right here where we pass in the section name, the section description, and this source string is all the results we got from web search, which we saved to state here. And we get the final section and we add it to our list of completed sections in our state. So now I want to show how we tie all these pieces together. So we talked about that research plan generation step. We showed that in isolation. So that's just taking the input topic from the user, an input kind of schema or outline of what you want in the report. And this produces a set of section objects, okay? Now we talked about taking one of those section objects and writing a section individually. Now what this final graph will do, it'll tie it all together. And what it'll do is it'll generate that plan and it'll automatically kick off writing of all those sections of the main body in parallel. So that's kind of point one. That's something that's really nice about LangGraph. It allows you to do that orchestration. This little dotted arrow here shows that what's going to happen in LangGraph is it's going to parallelize writing of all body sections of the report initially. Then later, after the main body is all written, it's going to gather those completed sections and it'll write any final sections that don't require research. That'll just be like the introduction and conclusion that don't need web research, and they'll kind of synthesize everything else we've written initially. So this two-stage process I found gives much better quality reports because it uses everything that's written here to write the final sections of the report, like the conclusion and introduction. If you try to write everything in parallel, the introduction and conclusion won't have awareness of the main body, so they can be totally disjointed. So it's actually very subtly important to do this sequentially to get better quality overall report styling and kind of introductory and concluding remarks. Now what's kind of nice is this is just what we already saw. This writing process is the same as what we just did. All that's happening is in this graph here, we're just parallelizing it. Now to parallelize things, we use this send API in LangGraph, and this really gets into some nice tricks you get out of LangGraph. So you can see this initiate section writing is what we call a conditional edge in LangGraph. Now what it allows you to do is we've done, for example, the planning step up front. We've saved the report sections to state in this sections key, and we can just iterate through all those sections and kick off section writing for each one all in parallel. So that's what the send API call is doing. You're just iterating through a list in your state, and you're kicking off a writing process for each element in that list, as long as that element in that section in particular requires research. That's really all that's happening here. So we can test that all running end to end, provide a report topic, provide a report structure, and we can see we get a final report out. Nice introduction, some comparison context, CPUs, GPUs, sources for both, nicely formatted, kind of a final strengths, weaknesses breakdown of each component. So again, this took about a minute. It was all automated for me by, in this case, Llama 3.3, served by NVIDIA NIM, and I get a lot of nice sources. So this kind of quick report generation and research is one thing that LMs are really good at, and I expect to become more and more common. Now I want to show something else that's kind of neat. I set my Langssmith API key at the start of this notebook, and so that means everything I did is actually logged to Langssmith. So I can go ahead and open this project in Langssmith, and I can see the entire flow of my multi-agent report writer here. I can open up each one of these nodes. So we did the plan generation. I can open this up, and I can look at all these chat NVIDIA calls to Llama 3.3, and I can actually look at the prompts and the outputs. So in this case, this was my query generation. I got some queries out. This is my overall section plan generation. There's the sections. Here are the two main body sections, one on CPUs, one on GPUs. I can dig in and look at all the individual model calls, the prompts, as well as the responses. Pretty nice. And again, I can kind of look through the final section writing, which is the introduction and conclusion, and the final compilation of the report again. So it's all here, also saved for me in Langssmith. Now what's kind of cool is I can go up and look at, okay, the overall latency was around 40 seconds. So what's kind of nice about this, you can see this overall report that we got, which is a pretty nice breakdown of CPUs and GPUs with a bunch of sources I can dig into, is like 40 seconds in time. So all that web research and parallelization of section writing is done for me. Now just to kind of wrap this up and conclude a bit, I do want to mention that going forward, we'll probably see more and more of this types of LLM-assisted kind of report generation. And that's because while RAG systems are really useful, RAG really shortens the time to get answers to questions, okay? But oftentimes, questions are in service of a bigger objective, like an organizational problem or decision, okay? So that's what's kind of neat about report writing beyond just question answering. reports can actually be synthesized and designed around particular organizational objectives that you actually want to achieve or decisions that you want to make. So just to conclude what we did, we built a multi-agent system for high-quality report generation. It's multi-agent because, one, it has this planning phase where an LLM, in our case, Llama 3.3, hosted by NVIDIA NIM, will reflect on the topic and the outline, produce some number of report sections, and then the whole downstream application is determined by the structure of those sections. So any sections that require research will kick off this research phase, where we're going to have an LLM produce search queries, run web search, reflect on the results, write a section. Those will all be parallelized. And then we'll have a second stage where we're going to have another LLM call that will reflect on the overall report body, write the introduction, write the conclusion, and then we'll compile that all into the final report, and we're done. Now, I did mention that Llama 3.3 is a really cool model. It's quite large, so 70 billion parameters, a bit too large to run locally for many people. And I found that NVIDIA NIM is a really nice alternative way to run the model because it's hosted for you and it's quite fast. As you saw, we ran this whole thing in around 40 seconds. And it provides a really nice option. So if you want to get started with Llama 3.3, it's a great way to go. And what's cool is that things, as you saw, like structured outputs are all supported. So you can build pretty sophisticated workflows just like we show here, all using LangChain's integration with NVIDIA. So hope you enjoy this, and feel free to leave any comments below. Thanks.